you are more intelligent. So what makes me intelligent makes me more intelligent over the pen or over the Apple Pencil are these four properties actually. These are the four properties which makes me more intelligent. And let me just quickly explain you these four properties, and then we will be able to understand the swarm intelligence. Actually, swarm intelligence is the one approach by which we can insert these four properties to this pen to make this Apple Pencil, right? So, to make anything intelligent, these four properties are required. So the first property is whatever it does is appropriate for its circumstances and its goals. Intelligent agent always do whatever is good for himself, right? You people are professors or the researchers. That's why you are attending this workshop. I'm a professor, so I am giving the lectures. I will learn something, you will learn something, right? So we will learn something through this workshop. Being a professor, even I will not take the job of truck driver. As a truck driver, I will rather take the job of delivering the lectures, right? So, and truck driver cannot give the lectures. I can give the lectures. I cannot drive the truck. Both the things. So intelligent agent understand that what is good for it. There are, suppose, two lectures are going on. If you are into the computer science area or the soft computing area of research, then you will rather want to attend this workshop, even if in this adjoining room another workshop is going on chemistry subject workshop is going on. You will not attend that workshop, you will attend this workshop, because you know that chemistry workshop is not going to help me, this workshop is going to help me, and that's why I should attend this workshop. Okay. Another property is that it is flexible to changing environments and changing goals. If the goals change, if you just left the teaching job, if you have left the teaching job, researcher job, and you have started your business, suppose your business is automobiles business or a truck company, a truck company you have started, transport company you have started, then if required, if your driver is on leave, sometime you may say that, okay, I will not lose my customers, I will drive the truck, right? I will drive the truck. So at that time you will be able to drive the truck, you will be ready to drive the truck, because that's your business now. So if the environment changes, goals changes. It learns from the experience. Means, the senior professors gets more salary than the assistant professors, because it is considered that the senior professors knows more than the assistant professor, than the new professors. So the new professors has less experience, means less knowledge. More experience means more knowledge. So a system is said to be more experienced equivalent to the more intelligent, right? So in the ANN based algorithms also it happens that more the data, better the system. More the data, better the system. More the experience, better the system. It makes appropriate choices. Last property is, if more than one choices are given, then the intelligent agent can understand that what is good for me. What is good for me? If more than two choices are there, if simultaneously with the same at the same time you are given two choices, then the intelligent agent should be able to decide that, okay, I should go on this path. It should not just hang. The computer should not hang. It should prioritize the things. If suppose simultaneously I have given the two commands on this computer, then the computer should understand that, okay, I should prioritize the commands and should execute one at a time, because I can execute one at a time. So it can take the decision that, okay, what should be done if more than two choices are given. Okay. This is the general framework of all the computational intelligence based algorithm, whether it is evolutionary, whether it is ANN based algorithm, fuzzy system based algorithm, swarm intelligence based algorithm. No matter which kind of algorithm you are dealing with, this is the general framework. What is the framework? Let me just quickly explain you. This is the agent. We want to make this agent intelligent agent. Deliberately, I made this the black box just to make that this agent doesn't know. It is not intelligent right now. It takes actions, and these actions initially are random actions. Some actions, random actions it will take. Then based on these random action, it encounters with the environment. It learns from the environment, and based on this environment, it observes, compare what is my goal, what is my past experience or prior knowledge, the agent becomes slightly intelligent. So based on one action, it becomes slight intelligent. Then based on this experience, it will take another action. In all these algorithms, all the computational intelligence based algorithms, we always keep in mind that the agents should not repeat the wrong decisions. Here, suppose some action has been taken, and this action, based on this environment, considered to be a wrong action. It is a wrong action. Then next time, agent should not repeat this wrong decision. It can commit another wrong decision, it can commit another mistake, it can take another wrong decision, that is allowed, but it is not allowed to repeat the mistakes, it is not allowed to repeat the wrong decisions, right? So every time it takes action, it becomes slightly intelligent, and so on and so on. Ultimately, it's an iterative algorithm. All the computational intelligence based algorithms are actually the iterative algorithms. Okay. So here I'm talking computational intelligence is the artificial intelligence based algorithm, where the artificial intelligence based algorithm which are computationally intensive can be said as the computational intelligence. And computational intelligence is further divided into three parts: ANN based algorithms, swarm intelligence based algorithm, and evolutionary based algorithms. I'm talking about the swarm intelligence based algorithm. Okay. Now, what is the definition of the swarm intelligence? Actually, everybody of us by default are using the swarm intelligence. So there is nothing to say that the swarm intelligence is started from the 1999 after the one of you gave the definition. No, it's not the case. But swarm intelligence is in the air, is in the behavior of humans, is in the behavior of all the animals, right? Whoever lives in a society from the inception of the nature. But of course, we have learned the intelligent behavior of swarm to make our algorithms intelligent. We are going to develop computer algorithms which are intelligent like the humans, which are intelligent like the birds, like the fish, like the elephants. So objective is the Bonaventure the first time understood the power of the swarm intelligence, and he gave this formal definition. Of course, before even 1999, the two most popular algorithms came into being: the particle swarm optimization in 1995, ant colony optimization in 1992. But at that time also people used to call these two algorithms in the field of evolutionary algorithm. You see the papers of 1995, 97, 98. At that time, even 2000, 2001 papers, you see people used to write particle swarm optimization is an evolutionary algorithm. It is actually a wrong statement. Actually a wrong statement. But after being understand that, okay, these algorithms has a separate one specific property by which these algorithms have been developed, and that property is the swarm intelligence, which is just opposite to the evolutionary algorithm. Let me tell you, in the evolutionary algorithm, like genetic algorithm, what happens? They are all the evolutionary based on the survival of the fittest, Darwinism principle. Whoever is the fit will survive. So what happens in the evolutionary algorithm? There is a population of individuals. Population of individuals means population of random solutions. They compete with each other. They do the competition with each other, and then intelligent behavior emerges. Intelligent behavior emerges there also, but that is based on the competition among the individuals in a group, in a population. There is a population, individuals are there, they compete with each other. Suppose there is a food, and food supply is limited, then the humans or animals or whatever, they will compete with each other. They will compete with each other. If there is a competition in a population, then the algorithm developed from that particular behavior is called the evolutionary algorithm. Right? Now just imagine a situation: if there is a population and individuals are cooperating with each other to make themselves better, means I know one algorithm. I'm speaking on that algorithm. Unfortunately, I'm not attending this workshop, but I wanted to attend because I do not know many other algorithms in the field of soft computing. So I also want to learn. So, if I would have been attending this workshop, then I would be learning another algorithm and I'm teaching one algorithm. So I'm learning, I'm teaching. Learning and teaching means now we both whenever the cooperation is there in the population to make the algorithm better, to create the intelligence, then the algorithm inspired from this kind of behavior is called the swarm intelligence. This is the basic difference: competition versus cooperation. In the evolutionary algorithm, there is a competition. In the swarm intelligence based algorithm, there is a cooperation. So cooperation is important in the swarm intelligence. And the same thing the one of you has mentioned, this is the emergent collective intelligence. It's a collective intelligence. It's not in intelligence of the one. If you know the fuzzy systems, I know swarm intelligence. You teach me fuzzy systems. I teach you swarm intelligence. Now, if you know both the algorithms, it is because of me. So it's a collective intelligence. You know one due to me. I know one due to you. Now it's a collective intelligence. So it is not the individual intelligence. It is the collective intelligence. Another thing, it is the emergent intelligence. The intelligence before attending this workshop, I didn't know fuzzy systems. Before attending this workshop, you do not know the swarm intelligence. But when we attended this, we both become intelligent, immersed. It is not inherent. I was not having fuzzy systems knowledge. You are not having the swarm intelligence knowledge. But when we attended, when we cooperated with each other, we become intelligent. So it is an emergent intelligence. It is the emergent collective intelligence of the group of simple agents. Of the simple agents means initially nobody knows everything. Means if I know everything, I will not attend the workshop. If you know everything, you will not attend the workshop. You are attending the workshop because you want to learn something new. Similarly, I want to attend the workshop because I want to learn something new. There are many examples in the nature of the swarm intelligence. You must have seen the birds flocking behavior. A swarm. Swarm means a group of individuals, a group of similar kind of individuals, like birds swarm, fish swarm. You must have seen ants swarm, honeybee swarm. All these are the swarm. There is a difference in the word group and the swarm. Group means, suppose suppose 10 persons went to the market. Suppose 10% went to the market. One person is went to market to buy the medicine, one to buy the sweet, one to buy the clothes, one to buy the cycle, one to buy the car, and so on. The objectives are different. 10 people are in the market. So these 10 people, this is a group of 10 people. This is a group of 10 people with different objectives. Now, suppose all the 10 people went to the market to find a shop of sweet of the best sweet shop in the market. 10 people, everybody is searching the best sweet shop in the market. Then this group of 10 individuals with the same objective, with the same group, is called the swarm. So there is a definition difference in the word swarm and the group. So every group is not a swarm. Group with same objective of all the individuals is known as the swarm, right? So, and you can expect the intelligence only when there is a same objective. If the objectives are different, then intelligent behavior will not appear. So group foraging of social insects, cooperative transportation, division of labor, nest building, collective sorting and clustering, all are the examples of the swarm intelligence in the nature. You must have seen the ants behavior, where the ants always find the shortest path from their nest to the food source. You just put some sugar, some sugar on one side of the room, and suppose there is some nest of the ants, then they will always find the shortest path, most convenient path they will find, right? They do not have the GPS. If I want to come to Meerut, I will follow the GPS. I want to come to CCU, then I will follow the GPS, because from the top, one can see the Meerut also, one can see my location also. So it can, satellite can guide me that, okay, this is the shortest path for you. But ants do not have the satellite. Still, they find the shortest path. How? Swarm intelligence, swarming. They cooperate with each other. Cooperative transportation, cooperative mechanism, cooperative behavior, which made them intelligent to find the shortest path. And let me tell you, ant colony optimization algorithm, which is inspired by the ants foraging behavior, is nowadays the most important, most popular algorithm for the robotic path planning problems. Now, these robots may be the drones also. So those path planning problems is a one very, very popular algorithm. Okay. Characteristics of the swarm composed of many individuals. I tell you that swarm is not like 2-3 people will make a swarm. Yeah, technically it's not a wrong definition, but you cannot expect the intelligence. If 3 people are there, they are going somewhere, they are searching something. Intelligent behavior is not guaranteed, right? But mathematically and empirically also, experimentally also, we found that 10 plus individuals are there, then you can expect the swarm intelligence. Another thing is individuals are homogeneous. In the swarm, intelligence, you have not seen that, okay, 1,000 ants are there and 5 monkeys are there. They are finding the shortest path from the nest to the food source. Ants and monkeys cannot make the swarm. Ants can make the swarm. Monkeys can make the swarm. Birds can make the swarm. Honeybees can make the swarm. So individuals are homogeneous because their capacities are different. Their capacities are different. If the capacities are different, then they will not cooperate with each other. The monkey will say to the ant, okay, you are so tiny creature. Why I will follow your guidance, right? Why I will waste my time to guide you? Because I can see the source. I can see directly from, because I'm a bigger individual, so I can see the directly. You are tiny, so you need to cooperate with each other, right? So if the capacities are different, if the efficiencies are different, in that case, the cooperation will not occur. And therefore, to have the cooperation, everybody should be at the same level. So homogeneous. Self-organization is another property of the swarm, which says that there should not be any central control. Means in the swarm, there is no leader. Nobody is guiding them. It is not like master slave concept. There is a concept of drone swarm. There we use the word master slave. Means there is a master drone and the slave drones, right? So in the swarm intelligence, in the true swarm intelligence, there is no master slave kind of concept. Everybody is same. Everybody has the same level. Means nobody is controlling them. Everybody has the same level. Means nobody is the vice chancellor. Nobody is the head of the department. Nobody is the dean. Everybody is a professor. Everybody is a professor, and everybody is doing is organized in itself. Self-organization means if I have a class, I will go to my class at 11 a.m. exactly, without any timetable, without any control. I'm doing it by myself. So that is a self-organization, no central control. Nobody is controlling them. Last property is the perception of environment. Environment means everybody is able to understand that what is my efficiency, how much I know, so that I can teach you that. Similarly, if I do not know that how much I know, I will not be able to learn from you, right? So if I know 2 algorithms, but you know 3 algorithms, then I will request that, okay, the third algorithm you teach me, right? So I only can understand, means I can request to learn the third algorithm when I know that I only know the 2 algorithms. Okay. This is the necessary and sufficient condition. Means if self-organization and division of labor is there, then you can expect the swarm intelligence. And if there is a swarm intelligence, the self-organization and division of labor will be there. Means it's a necessary and sufficient condition. So these are the 2 properties, self-organization and division of labor. how to achieve the self-organization. How to achieve the self-organization. Just to achieve the swarm self-organization, I told you that everybody is working independently. Nobody is leading them. Independently means they are cooperating, but nobody is leading them. Nobody is the master. Nobody is the manager. And this property can be achieved by these four properties. One is the positive feedback. Positive feedback says that whenever, suppose 10 people are searching something in a given area, and one person says that I'm more close to you as compared to you, I'm more close to the solution or that particular thing, then I should respect. Some person say that I know more than you, then I should respect it, and I should follow that particular path. I should follow that particular path which that one person is moving. Negative feedback is just opposite to this. If somebody is giving me some information, I should not follow it. I should have confidence in myself, cognitive confidence. Positive feedback means social confidence. What others are saying, I'm following it. Negative feedback means I'm not following others. I'm listening my conscious, right? Cognitive learning. And self-organization can be achieved when we balance both. Actually, positive feedback and negative feedback are contradictory to each other. They are contradicting each other. But in the swarm intelligence based algorithm, we need to maintain both simultaneously. So the balanced positive feedback and negative feedback is required. And this balancing the positive feedback and negative feedback is one very important phenomena. And a lot of research papers have been written to balance this positive feedback and negative feedback actually. And in fact, today itself, this positive feedback and negative feedback concept is still an open area, is still a open area for the research. People are still working, and hundreds of the paper are coming to balance the positive feedback and the negative feedback. Every year, hundreds of the papers are coming just on this concept. Okay. Another thing is the fluctuation. Fluctuation means if somebody says to me that, okay, you do this, you follow this path, then I will not follow exactly this path. I will take left, right also, so that I can explore whatever he has explored. That's okay. I'm exploring that, but simultaneously I will explore left, right also, something which he may have missed. This fluctuation is important because if the fluctuation part is not there, then your algorithm will converge, will stagnate in just few steps, and you will not be able to explore the entire search space. If whoever is guiding you at this moment, suppose whoever is better than you, if he has missed the solution, just close, then you will also miss the solution, and everybody will miss the solution. Everybody will be misguided if the fluctuation is not there. So randomness is always required. So all these algorithms, like, you must have attended some lectures on fuzzy theory. You must have attended some lectures on ANN, artificial neural network systems. All these things requires the randomness, stochastic decision making, probabilistic decision making, and that is the soul of these algorithm. Probabilistic decision making is the soul of these algorithm. So all decisions are taken as the probabilistic decision, random decision. But random means not fully random, probability based. Means if somebody is guiding me that, okay, the solution is in this side, the probability of going to this side is higher as compared to other side. But other side probability is not zero. So the probabilistic, every time I'm taking the probabilistic decision. Okay. The last property is the multiple interactions. Multiple interactions means suppose 10 individuals are there, and they made, suppose these are the 10 individuals, and these two are the friends, these two are the friends, and these two are the friends, and these two are the friends. Means only these two are talking to each other. They are talking like this, and whatever they have explored, they are not sharing with these two. Then It is not a swarm. It is not a swarm. Actually, what should happen that if they two are the friends, then these two are should be the friend, and these two should be the friend. So actually, among four, there are three groups: one, two, and three. So whatever they know, they it will be communicated via this to this, and then this will communicate it to him, and this will communicate to him, and so on. Right? This is called the neighborhood topology. Actually, right, among four, so multiple interactions. I should not be just connected to my neighbor, just one person. I should be connected to many, so that whatever I know, I should be able to say to everybody, and whatever the information required, I can get it from many people, right? So multiple interactions. Okay. Division of labor. What happens that, okay, it is not necessary that everybody is doing the same work in the group. Some people can do can search in that particular area. Suppose this is your search space. Suppose this is your search space. Then some people can search here. Some people can search here. Some people can search here, and they can guide with each other, right, simultaneously. So this is called the division of labor. Okay. If you have an optimization problem, and your optimization problem is non-differentiable, non-convex, highly nonlinear, have local optima, it's a discrete problem, large size discrete problem, you require higher search speed. In that case, the swarm intelligence is swarm intelligence based algorithm helps. Okay. Now the research is huge in swarm intelligence. Introduction of the means what kind of research you can do in the swarm intelligence. You can introduce the new swarm intelligence algorithm. Can you give me just 1 second? Just 1 second. Just a second. Introduction to new swarm intelligence. We can develop, research areas. If you want to make your career in the swarm intelligence, then these are the certain areas where we can do the research. You can introduce the new swarm intelligence based algorithm. You can hybridize a number of swarm intelligence based algorithm. For example, particle swarm optimization is the one algorithm. Issue is one algorithm. You can hybridize and can make a new algorithm. You can modify the existing swarm intelligence based algorithm, because these algorithms are actually highly adaptive algorithm. According to the problem, you can modify the algorithm. And of course, if you are not good, you would not like to work in the development of the algorithm, you can apply the algorithms. You can apply the algorithms for your particular problem. Okay. This I already discussed. Okay. Here is some swarm intelligence based algorithms. So of course, let me tell you, hundreds of the swarm intelligence based algorithms are there. This list of swarm intelligence based algorithm is not the exhaustive list. Hundreds of the swarm intelligence based algorithms are there. Particle swarm optimization is the one, and ant colony optimization. These two algorithms are actually the most popular algorithms. This algorithm, ant colony optimization, was developed in 1992 by one Italian scientist, Marco Dorigo, based on the foraging behavior of ants, how ants find the shortest path from one point to another point. And this algorithm has been applied to many pathfinding, shortest path planning problems. Particle swarm optimization is inspired by the birds flocking or fish schooling behavior. Birds flocking, how the birds fly together. The rule is very simple. They cooperate with each other. They just share the information with their neighbors. If this is the bird, then it will share the information with these. If this is the one bird, then it will share the information with these three, right? So, whenever the one bird is moving, other birds can move accordingly. Artificial bee colony algorithm is inspired by the foraging behavior of honeybees. How the honeybees forage with and find the location of the flower with highest nectar. There is a nest of the honeybees. The nearby flowers are there. Whenever one honeybee extract the nectar and return to the hive, then this bee do the different kind of dances to inform to the other bees that okay, that particular flower is in this direction at this much distance, and this type of flower it has this much nectar. Lot of information it gave to other bees, and other bees then recruit themselves to the to the to that particular flower. Spider monkey optimization algorithm is inspired by the foraging behavior of spider monkeys. Spider monkeys is a special category of monkeys which live in the deep forest, and when they suspend with the tree branch, right, they look like spider, and therefore they are called spider monkeys. These spider monkeys have a very special kind of foraging behavior. Actually, what happens? They live in the group, they start foraging, and whenever they find the food, they start eating it. And if there is a scarcity of food, they do not start competition. If there is a less food as compared to the group side, they do not start competition. What they do, they divide themselves into smaller groups, right? They divide themselves into smaller groups, and a smaller group stays there if it is sufficient for that, and other group starts searching another food source, and so on. And this process continues till evening. Next evening, sorry, in the evening they come to the tree or wherever their habitat, and they share the information with each other that okay, I went in that particular direction, I went that particular place, the food was this, food was this, food was this. So next morning they find the most optimal location for their food source, right? So in this is a very special kind of foraging behavior, and we developed this algorithm. Myself, my three other co-researchers, one is the Maurice Clark from the France, who has a pioneer work in the particle swarm optimization, is my co-researcher in the spider monkey optimization. Another was my two PhD students of that time. Now they are the faculty members, Harish Sharma and the Simpi Singh Jadhav. So this algorithm is inspired by the foraging behavior of spider monkeys. Okay, that's all. Now, actually, in the further slides, I have the details of PSO, details of ACO, or all those algorithms. So that's not possible, but I'm okay to take few questions on the swarm intelligence. My objective was to introduce this subject. My objective is to introduce the algorithm, how the algorithm are inspired from different natural phenomena, and the people who are interested to simulate the nature into a computer algorithm are most welcome in this area, and I'll be very happy to work with the people who have some ideas to convert the nature into the computer algorithm. Thank you so much. I'm okay to take the questions. We have still 5-7 minutes, so we can take the questions. I hope you can hear me.
Yes, sir. I am audible. Okay.
Okay.
Anyone have some query? No.
I hope people were listening.
Ji, sir. Yes, sir.
Hello, sir. This is Tarun, research scholar in the Department of Mathematics. Can you share an example of successful application of meta-heuristic algorithm in a specific field in our practical life?
So I started my lecture with the applications. Prosthetic hand means this robotic hand. So in the robotic hand there are many joints. So these joints should be working in synchronous. They should cooperate with each other. So now one joint is the one bird or one ant. One ant. Now they should cooperate with each other. Only then this hand will work like a hand, right? Similarly, your CPU may have different cores. They are working together in cooperation. Only then they can give the output, signal output in cooperation. So, anywhere you see the life, you will see the practical applications of the swarm intelligence of the meta-heuristic algorithms.
Thanks, sir. Sir, one more question. Suggest some one or two research question currently for meta-heuristic algorithm, open research questions.
So I ended my lecture actually again. I don't know whether you were listening or me or not, but I ended my lecture with these open questions, open research areas. That the first is you can introduce the new swarm intelligence based algorithm, because there is always a need of algorithms. There is always a need of algorithm, the no free lunch theorem. So you can introduce the new swarm intelligence based algorithm. If it is not possible, then you can modify the existing swarm intelligence based algorithm. If that is not possible, you can hybridize the two swarm intelligence based algorithm, or one swarm, one evolutionary, you can hybridize and can make a new algorithm.
Thank you. Thank you.
Or of course, if you are into the field of the engineering or application, then you can think of those applications right now. Like I'm also a mathematics student, so I'm these days using the swarm intelligence for the drone swarm. How the drones, a group of drones, cooperate with each other and can make more intelligent decisions in the sky, live. In the real time, they can make that intelligent decisions. So I'm working on those applications these days.
Okay.
Thank you, Professor Bansal. Any more query, any more question from the participant? Thank you, Professor Bansal, for a nice and insightful talk.
Thank you.
I'm sure that all the participants be benefited with your expertise in swarm intelligence and other meta-heuristic algorithms. And if any participant have a question or further query, then he can mail to Professor Bansal, and
Definitely.
he get the time, he will answer your queries. So thank you. Now I invite Miss Ritu for a formal vote of thanks.
Thank you so much, sir. Good afternoon to everyone. On the behalf of organizing team, I would like to extend my heartfelt thanks to Professor J.C. Bansal, sir, for their insightful and engaging
Vote
presentation,
of thanks.
who spared time from his busiest schedule to graceful occasion. Today, we had an opportunity to hear the importance of swarm intelligence for solving the problem. On the behalf of organizing team, I would like to extend my heartfelt thanks to Professor J.C. Bansal, sir, for their insightful and engaging presentation,
Vote of thanks.
who spared time from his busiest schedule to graceful occasion. Today, we had an opportunity. Thank you so much, sir. To hear the importance of swarm intelligence solving the problem. On the behalf of organizing team, I would like to extend my heartfelt thanks to Professor J.C. Bansal, sir, for their insightful and engaging presentation, who spared time from his busiest schedule to graceful occasion. Today, we had an opportunity. Thank you so much, sir. To hear the importance of swarm intelligence solving the problem. On the behalf of organizing team, I would like to extend my heartfelt thanks to Professor J.C. Bansal, sir, for their insightful and engaging presentation, who spared time from his busiest schedule to graceful occasion. Today, we had an opportunity. Thank you so much, sir. To hear the importance of swarm intelligence on the behalf of organizing team, I would like to extend my heartfelt thanks to Professor J.C. Bansal, sir, for their insightful and engaging presentation, who spared time from his busiest schedule to graceful occasion. Today, we had an opportunity. Thank you so much, sir. To hear the importance of swarm intelligence on the behalf of organizing team, I would like to extend my heartfelt thanks to Professor J.C. Bansal, sir, for their insightful and engaging presentation, who spared time from his busiest schedule to graceful occasion. Today, we had an opportunity. Thank you so much, sir. To hear the importance of swarm intelligence
Thank you so much for the support.
I would like to extend my heartfelt thanks to Professor J.C. Bansal, sir, for their insightful and engaging presentation, who spared time from his busiest schedule to graceful occasion. Today, we had an opportunity. Thank you so much, sir. To hear the importance of swarm intelligence.
Thank you so much for the support.
I would like to extend my heartfelt thanks to Professor J.C. Bansal, sir, for their insightful and
He will deliver his lecture, and I hope that lecture will surely create interest in you that the things how going on and how technologies are developed in teaching and other areas. So I hope you will enjoy that lecture.
I have 3 books that I want to share with you.
you.